Okay, chemistry, we're on to a very important topic, mass stoichiometry. This is how to use a chemical equation to compute how much of a product you're going to get and how much reactants you need to put in. So we measure things in grams. We have scales to do that in the lab, and so that's our world. We're able to measure how much things weigh or what their mass is. But we need to get things into moles. That's a number of particles. And those are massive numbers. As we know, a mole is 6.022 times 10 to the 23rd. And a molecule is something very small that we can't see. So we need to use weight to convert into how many particles we have, how many moles we have. So if we know the substance, it can either be a gas, liquid, or solid. We can compute the number of moles using a molar mass conversion. So that equates the moles of a substance, 1 mole of a substance, to how many grams it weighs. So in the case of carbon, 1 mole of carbon is 12.01 grams. You get that off the periodic table. I think of that as a translator. We speak in the world in the measures of grams, and chemical equations speak in measures of numbers or of moles. And so we need a translator to get us between those two, and the molar mass conversion does that. So we're going to do 3 problems, and what I use is, and what have you use, is kind of a graphic organizer. All right, so you can see up at the top, are the measures of things in grams. Now you don't have to have all of these, you only need to have the one that you're interested in. Down in the chemical equation, in the blue dashed box, that's the chemical world. Okay, that's in moles. And so in between those two, our world and the chemical world, we have the molar mass translators. You can see one for methane, CH4. You can see one for oxygen, O2, for carbon dioxide, and for water. So we use those to get us between grams and moles. So let's go ahead and do this problem. How many moles of CH4 are required to form 8 moles of H2O? All right. So what we're trying to get to is moles of CH4. So you always start off with what are you looking for? And we're going to start with 8 moles of H2O. And you see that's down in the box below. So we need to get from where that 8 is over to where the question mark is. Okay, so we have 8 moles of H2O. And we're trying to get to some number of moles of CH4. So what we need is a relationship between moles of H2O and moles of CH4. And that is you get that straight out of the chemical equation. 1 mole CH4 equals 2 moles of H2O. You can see that down in the chemical equation. We don't care about O2 or CO2 in this problem, so they have nothing to do with this. Now what you can do, that's called an equivalency. 1 mole CH4 equals 2 moles H2O. You can create 2 conversion factors. You put one side over the other. In this case, we'll put 2 moles of H2O over 1 mole of CH4, or you flip it. You put 1 mole CH4 over 2 moles of H2O. Those are both true statements, but only one of them is going to help us solve the problem. So how do we choose which one? We got to make a choice there. So here's how we choose. We're going to choose the one on the right. We're going to put it there. Now, why did we choose that one? Because for our final answer, we need moles of H2O to cancel out and moles of CH4 to appear. Therefore, we want moles of H2O on the bottom of the conversion factor and moles of CH4 on the top. So you see that moles of H2O and moles of H2O cancel. And the only unit remaining is the moles of CH4, which is what we want in our final answer. And so now that we have the units set up correctly, you simply do the math. And that's going to be 8 times 1 divided by 2. And if you do the math on that, you get 4 moles of CH4. What the equation is saying is we ended up with 4 moles of CH4 from 8 moles of water. And that is our final answer. Okay, let's look at another one. This one's a little more involved. So how many moles of CH4 are required to form 3.2 grams of H2O? So now what we're going to do is we're going to go ahead and place a question mark in moles of CH4. And we are going to put 3.2 in the grams of H2O. So notice we're up for 3.2, we're up in the grams row, and we're above H2O. Okay, and then the question mark goes down in the moles row, and it goes above CH4. So we need to get from 3.2 to CH4. Okay, so we see that we have 3.2 grams of H2O, and we need to get to some unknown number of moles of CH4. So now we're going to set up our, let's first of all see what the path is. You need to go down through the molar mass to get to moles of H2O. Once you're there, you move across to get from moles of H2O to moles of CH4. In other words, if you want to go from side to side, you have to be down in the chemical equation. Why? Because that's the only place we have relations between all the reactants and products. 1 CH4, 2 O2, 1 CO2, 2 H2O. We don't have any relations in grams, so we can't move side to side up in the grams row, only down in the moles row. So let's go ahead and set up our equation. You can see up above, on the right, we have some number of moles of CH4, what we're looking for. We start with 3.2 grams of H2O, and now we need to first get from the 3.2 grams of H2O down to moles of H2O. So we use the molar mass conversion for that. We're going to have two conversions. How do you know that? Because there's two different arrows. There's one going down and one going across. Okay, so our first equivalency is the molar mass of water. 1 mole H2O equals 18.02 grams of H2O. So now we can make two conversion factors out of that. There's 18.02 grams of H2O for every 1 mole of H2O, or there's 1 mole of H2O for every 18.02 grams of H2O. Those are both true statements, but we're only going to use one of them. Which one? We decide to use this one. So we'll put it up there. So again, you see that grams of H2O, 3.2 grams of H2O on the top cancels with grams of H2O on the bottom. That's what we want. We want that to go away because it's not in our final answer. Okay, so now you see, if you did that calculation, 3.2 grams H2O times 1 mole H2O over 18.02 grams, and you do not do this calculation, but if you do, you'd get 0.18 moles of H2O, and you see that down in the bottom right red box. Now we need to get from moles of H2O over to moles of CH4. So again, just like the last problem, we get that equivalency out of the chemical equation. And it's simply 1 mole of CH4 equals 2 moles of H2O. It comes straight out of the equation. Okay, so now we need to make two conversion factors out of that. There they are. You need to choose which one are you going to use. Think about it. Which one of those two are you going to use? And the answer is we're going to use this one. And you'll see why. Because now you have, in the first conversion, you have moles of H2O on the top. In this second conversion, you have moles of H2O on the bottom. So they cancel out. That cancels with that. Notice we're not doing anything with numbers. We're only canceling units of measure. So now the only unit of measure left is moles of CH4. I call that the last man standing. It's the last unit that wasn't canceled. So if that doesn't match the one you have in your answer, moles of CH4, it means you set the problem up incorrectly. But it does match, and so we can go ahead and do our calculation. So we have 3.2 times 1 divided by 18.02 divided by 2. You multiply everything on the top and divide by everything on the bottom. And when you do that, you get 0.094 moles of CH4. And if you're so inclined, you can go down to the box on the lower left where the question mark is, and you can go ahead and replace that. There's no need to do that, but that's where that number would go. Okay, we're going to do one final problem. This one's a little bit longer. So how many grams of H2O can be formed from 5.2 grams of CH4? Okay, so we put the 5.2 grams in the grams row above CH4. So it's in the CH4 column in the grams row. And we're going to put the question mark over above H2O in the grams column. So you see our question mark over there on the right. So we need to go from the 5.2 to the question mark. So the question is, can we go straight across? And the answer is no. We don't have any relationships between grams of CH4 and grams of H2O or any other number of grams. So the only way we can do it is to go down into the chemical equation, and like this, we're going to go through the molar mass. Then once we're in the chemical equation where we have relationships, 1 mole CH4, 2 moles H2O, We'll get a number there. We come across from there to there, convert moles of CH4 to moles of H2O. And then once we get that, we come back up out of the chemical equation to our final answer of grams of H2O. So that's going to require 3 conversions. Down from grams of CH4 to moles of CH4, from moles of CH4 over to moles of H2O, and then back out from moles of H2O to grams of H2O. So here we go to set up the equation. And there you see, way over on the right is what we're looking for, grams of H2O. And way over on the left is what we're starting with, 5.2 grams of CH4. And since there's 3 arrows involved here, we need 3 different boxes. So the first equivalency we're going to use is the molar mass of CH4. And that's 1 mole CH4 equals 16.05 grams of CH4. Now you create your 2 conversion factors. There's the first one, there's the second one. Which one are you going to use? We're going to use this one. 1 mole CH4 for every 16.05 grams of CH4. Now we can cancel grams of CH4 and grams of CH4 there. And now we're sitting in the box of moles of CH4. Now again, you're not going to do this calculation, but if you did, you would get 0.29 moles of CH4. You see it down there on the bottom red box. Now we need to get across from moles of CH4 to moles of H2O. So we're going to go ahead. What's the equivalency for that? You get that one straight out of the chemical equation. 1 mole CH4 equals 2 moles H2O. So now we create the 2 conversion factors. There they are. Decide which one you're going to choose. This time we're going to choose this one. Why? Because when we bring it up here, moles of CH4 cancels with moles of CH4. Now we're sitting in the box of moles of H2O. That's over there on the bottom right, and you see it's 0.58 moles of H2O. Okay, now we need to get back out to our final answer to go from moles of H2O to grams of H2O. So for that, we use what's in the blue box. We use the equivalency of 1 mole H2O equals 18.02 grams H2O. Make the 2 conversion factors. Think about which one do you want to put up in that box. You're going to put this one because you have moles of H2O on the bottom. So moles of H2O in the second conversion cancels with moles of H2O on the bottom of the third, and you've taken care of that. And now the last man standing is grams of H2O, and you can see that matches up with what we're looking for in our final answer. If the last man standing, the last unit that you didn't cancel, does not match what you have in your answer, you set the problem up incorrectly. So now we can go ahead and do the math. So if you look over at the left, 5.2 times 1 times 2 times 18.02, and you divide by everything on the bottom. So divided by 16.05, divided by 1, divided by 1, and when you do the math on that, you get 2.9 grams. And if you're so inclined, you can write it in the box with the question mark, and there it is right there. Okay, so this takes care. You're going to get a lot of practice with this. It's a long assignment, and this is how you do the 3 problems we just did are the first 3 on your assignment. And so go ahead and do those, and hopefully you get the hang of it very quickly. And so that takes care of this lesson, and we'll be using this principle throughout the course, molar mass stoichiometry.